Okay, at least that one tells me it's recording with a red light. All right, Unit 16. Unit 16 is all about integrals and what they mean for areas. Now we've kind of already hit on this subject a couple times, talking about as long as we have all positive y values, the integral from a to b represents the area under the curve, between the curve and the x-axis. We've already talked about that. We can specifically say that is the area under a curve because, well, when the whole thing exists above the x-axis, you have space under it. You have seen this image before. It's just saying that the area is the integral from here to here, and it only represents this area because every one of these y values is above the x-axis. And that's what today's lesson is about, is strictly finding those areas. That's all we have to do. So it's really just integration, and we're talking about areas that are only above the x-axis. Tomorrow we'll start talking about areas that are above or below or both, and things like that. So it says find the area of the region enclosed by this curve, which, by the way, this is a quadratic that's been shifted up one, so it is always above the x-axis. X equals 1 and x equals 2. A picture's not necessary, but it helps. It actually would look a lot like this. So I'm just going to copy that. Oh, picture drunk. Okay, so from picture way wrong, not scale at all, from 1 to 2. So yeah, we're just trying to track down this area. That's all we're trying to do. Should be pretty darn easy. We're not doing trig or anything yet. So our area will be equal to the integral from 1 to 2 of x squared plus 1 dx. We're just going to have to spot integrate this one. It's real simple. There's no trig, there's no exponentials, there's no substitutions. That doesn't mean it won't come up. Yes, you are expected to be able to do that stuff with all of the types of integrals, including substitutions and trigs and all that stuff. But this one starts off pretty darn easy. X squared, we bump the exponent up by 1 and put the reciprocal of its new exponent on front, and then just plus x. Now we don't have a plus c because this is a definite integral, meaning we have a beginning and an end, so there is no plus c. We would be evaluating this, and you know what, I'll even change colors for this. We'll be evaluating this from 1 to 2. But the way that works is we plug in 2, and then we subtract us plugging in 1. It's always end minus beginning. End minus beginning. So we have 1/3 of 2 to the third plus 2 minus 1/3 of 1 to the third, which is just 1, plus 1. Uh-oh, get skinny math, running short on space here already. Is this 8/3 plus 2 minus 1/3 minus 1. You have to make sure that you distribute that minus sign to both the 1/3 and the 1. 8/3 minus 1/3 is 7/3. And 2 minus 1 is positive 1. And if we call 1 3/3, we get 10 over 3 is the area under the curve between the lines x equals 1 and x equals 2. That wasn't too bad, was it? Okay, 2 questions. Hold on 1 second. So, Harrison, you were asking me how would this look? You could just area equals 10 over 3. And Bria, I didn't square it. This is me evaluating from x equals 1 to x equals 2. No, normally we would have done that with just a vertical line, but this is the way that the textbook shows it, so I just figured I'd show it their way. Yeah, this is me evaluating. It's another reason why I changed the color. That way it didn't look like exponents. Is that okay? Better that way? Okay. Other questions, or is this okay? So far, so good. Okay. Well, the next example is going to involve some trig. Find the area enclosed by one arch of y equals sine of 2x. Man, that sine wave felt good. Now, typically sine and cosine would have a period of 2 pi. But remember, the period of a sinusoidal graph is going to be 2 pi over b, where b is the value that sits in front of x. So our period length is 2 pi over 2. So this sinusoidal has a period of pi. And if you can recall that all sinusoidals, both sines and cosines, can be split into 4 parts.
Sinusoidals?
1, 2, 3, 4. That means this is pi. So halfway through it, right here, which finishes off one arch, would be pi over 2. Ask. This is a horizontal shrink, factor 1/2.
Got it, okay.
Okay, because it's 2 pi over that b value, which takes our period from 2 pi and shrinks it down to a single pi. And then we cut that pi into fourths, and we see that one arch, we'll be finding this area, one arch is from 0 to pi over 2. So those are our limits of integration. Our area then, which would be capital A, equals the integral from 0 to pi over 2 of sine of 2x dx. Now when we go to integrate this sine of 2x, we have two options. We could use a small substitution where u would be 2x, or we could just realize that if you were to find a derivative of sine or cosine, whatever, that its argument is 2x, the chain rule will create a 2 in front. So this is called integrating by inspection instead of by substitution. We know that this thing is a derivative, and it should have had a 2 in front of it. That 2 is missing. That means when we integrate, we'll have to put a 1/2 on the front of it. And if none of that makes sense, I could do a u sub real quick if you'd like me to do it that way. No, thank you? So everybody's comfortable with why this is going to have a 1/2 on the front of it in a moment.
Is it a reciprocal?
No. I'm going to go ahead and do a u sub. I'm going to go ahead and let u equal 2x. Because if u is 2x, then I can say that du is 2 dx. I don't have a 2 dx. I just have a dx. So I need to substitute in for dx. I need to isolate this dx. I'll multiply both sides of this equation by 1/2. So I get 1/2, there's where the 1/2 is coming from. 1/2 du equals dx.
Oh, that makes sense.
So now we'll make that substitution. I'm not going to put my limits of integration on there. The reason why is because those limits of integration are x values, and I'm now working with u's. I'll put them back on when I resub back in for the 2x. Okay. This 1/2 in front of the du, I could put this in the front of the integral. So I'm going to say 1/2 integral of sine of, I've replaced 2x with u, and dx has been replaced with this 1/2 and a du. Like that. See the 1/2 in the du, that is dx. Remember when you're integrating, you're doing the reverse, the opposite of derivative. That means sine here is the derivative. So I ask you, what is sine the derivative of?
Cosine.
Not cosine.
Negative.
Negative cosine. Sine is the derivative of negative cosine. So negative 1/2 cosine of u. I'm not going to say plus c because we do have limits of integration on our x's. All we need to do is replace the u back with a 2x. So we have negative 1/2 cosine of 2x. And we will evaluate, and Bria, maybe I'm probably not alone, got a little stumped by these red brackets that I used, so I can just use the same symbols that I was using before, and say from, what are we going from, 0 to pi over 2? I'm running on space. Get skinny, math.
Get like Gavin.
Yeah, get loud, math.
No, get fat.
Plugging in pi over 2. 2 times pi over 2 is just pi. So it gives me negative 1/2 cosine of pi minus negative 1/2 cosine of, well, 2 times 0 is 0. It would be helpful if you knew your trig, if you knew your unit circle, because cosine of pi is negative 1. Because cosine begins at its maximum of positive 1, and it ends at its maximum of positive 1, that is a period of 2 pi. This is halfway across that. So this is where its minimum is, negative 1. So it gives me negative 1/2 times negative 1 plus, well, I already said it. Cosine begins at its maximum, so cosine of 0 is just 1. So that gives me 1/2 plus 1/2. Oh, the area beneath one arch of sine of 2x is equal to 1. Exactly 1. Isn't that neat?
No.
Yeah, it is. Crazy? No, it's just neat. It's just neat. I mean, this is a curve, right? I know sometimes when I say things like that, it's like I'm alluding to something. Like, not that I know of. It's just neat. Because if you think about it, this is the area of a square that's 1 by 1. So there's a 1 by 1 square right here that has an identical area as this curve. It's just kind of neat. It's just nerdy neat, you know, that's all.
I think your love for math is entirely lost on this for us.
Some people. It's okay. That's all right. I don't teach because I know everybody's going to love math. I teach because I hope that someone will.
That's fair.
Yes, Bria. Yes? Yeah, that's what I have. It's 2 dx. I had it right here. And then what we did is we replaced this. So we said we didn't have this 2. It didn't exist. So I had to get rid of the 2 by dividing both sides by 2. But that's the same thing as multiplying both sides by 1/2. So I turned it to 1/2 du equals dx. And then I said, okay, I can replace things now. This 2x is now a u. And this dx is now a 1/2 and a du. And they're right here. But right, we took the integral of sine, which is negative cosine. And I didn't write the limits of integration because those limits are actually x values. So I turned it back into x's, and then I have my limits of integration. Because u is 2x, been replaced as a 2x, boom, now I can plug in. Okay? All right. Now the next question is very similar. What we have here is half of an arch of a cosine wave. And we could see that this one goes from 0 to pi over 6. This one goes from pi over 4 to, anybody know?
Pi. 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 1/2.
It's not pi, it's half of a pi.
I said 1/2.
Yeah, he said 1/2, but it's pi over 2.
I said 1/2, you said pi.
Yeah, exactly.
Yeah, okay, there you go.
Together.
It's pi over 2.
We were talking about ours multiplied together.
Wow, together, put both of you together, you make a full brain.
Yeah, but if you multiply 1 times 1 is still 1, and 1/2 times 1/2 is 1/4, so that's like scary. Alrighty, so now the question is, which of these regions looks larger? I mean, I know which one looks larger to me.
Stop being so mean.
A looks larger. And honestly, I don't know. I have no clue. I've never done this question. A looks larger. But I don't know. I get the feeling that we were supposed to say that A looks larger, but it turns out B is larger. I don't know.
Yeah, I'm just gonna put down B.
I am going to be a little surprised if B is larger, though, because my eyes are telling me that A is bigger. But let's go ahead and see what's happening. I'm just picture not drawn to scale. I think the picture's to scale. Hey, but you know what? The problem is we don't do very well at estimating curved areas. That's our problem. We're really good with squared off areas, you know?
Yeah, but you didn't manage. Looks like
I know, it just looks that way. I know.
I bet you B is gonna be bigger.
That's what I'm thinking. Let's figure it out. Here's what we know. We do know either way that we're going to be integrating cosine of x. So I'm not going to do this integration twice. I'm going to do the integration once and then just evaluate with 2 different sets of limits of integration, because they both have the same function, y equals cosine of x. So area, and I'm not going to write a equals because there's already an a, so this time I will write area. Area equals the integral of cosine x dx. Area. My God.
I swear you said era.
This one integrates very easily. Cosine is the derivative of sine. So we have sine of x. And I'm not going to say plus c. Instead, I'll say integrated from a to b. How about that? And what we will do is we will plug in our 2 different limits of integration. So for this one, I will write a equals, and for the other one, I'll write b equals, representing the area of a, the area of b. Good color, good color. Pink's a good color. Area A is going to be sine of x evaluated from 0 to pi over 6. That is sine of pi over 6 minus sine of 0 It would be great if you knew your unit circle, or you knew how to find the sine of pi over 6, because I don't have the unit circle memorized.
Easy.
So what I would do is I would draw myself a cheesy little triangle, pi over 6 in quadrant 1. Picture not drawn to scale, it never is.
Cheesy little triangle.
Pi over 6 is 30 degrees. This is one of my special right triangles, and a 30, 60, 90 is always going to have the classic values of 1 across from the 30, root 3 next to it, hypotenuse of 2. Sine, being y over r, or opposite of our hypotenuse here, gives us 1/2. And sine of 0 is just 0, because it's y over r, and if you're here, there is no y value. So this is just 1/2. Oops, that's not pink, that is red.
The area is just 1/2.
The area of section A is just 1/2.
Cool.
Now I'm getting the feeling that it might be equal. I don't know. We shall see, shall we? Shan't we? Shan't we? Shall we? I don't know.
I definitely feel like B is going to be larger.
Play the opposite.
Just because it has a larger,
Span?
yeah.
You're right, that's a span of pi over 4.
Yeah, instead of 5 and 6.
Maybe. So again, sine of x from pi over 4 to pi over 2. So much noise. Pi over 4 is a 45-degree angle. Oh, I forgot to write it. sine of pi over 2 minus sine of pi over 4. Anyway, a 45-degree angle is pi over 4, so I'm going to go ahead and draw that up. Having the classic side values of 1 root 2. Classic. And sine is y over r. So this second expression, sine of pi over 4, is going to be 1 over root 2. So I have a minus 1 over root 2. But sine of pi over 2, sine of pi over 2 is just 1. Yeah, because if you're up here, you're at the coordinates on the unit circle, the coordinate of 0, 1. So y over r is going to give you 1 over 1.
1.
So it's just 1.
1 minus.
And 1 minus 1 over root 2, I'm not really sure what the size of that is. So what I'll do is I'll rationalize this denominator. You know what? It may or may not be. I'll be honest with you, I'm not very good at seeing that. So I'm going to rationalize my denominator here. Gives me root 2 over 2. 1 minus root 2 over 2. And if we call 1 a 2 over 2, we get 2 minus root 2 over 2. So which one is larger? Well, here's what we know about the number square root of 2. It's bigger than 1. I see people standing up trying to see. We know that the number square root 2 is larger than 1. That means this 2 minus root 2 will be smaller than 1. Because this value is larger than 1. 2 minus something that's a little bigger than 1 gives me a value between 0 and 1.
So A is bigger.
That makes the top of this fraction smaller. So A does have a larger area. Out of curiosity,
That is. That owl.
2 minus the square root of 2 is divided by 2 is. Wow, it's actually a lot smaller.
Soda.
Yeah, wow.
Even though it's water, it doesn't have that much. Like,
Yeah, I mean, I honestly thought they were trying to trick us, but hey, you know what?
I'm sorry. My throat really hurts.
Okay, before I go on to the back, I think there's a back. Oh, there's not. Oh, well, then never mind. Are there any questions about this before I stop the video in case they need to be heard? No? Okay, well, let's see when we stop the video if it works or not.